Hello everyone, I'm Twinan from Shanghai Jiao Tong University. Thanks for listening my presentation. Today I will present my work, Zero-Shoot Program Representation Learning. Learning program representations has been the core prerequisite of code intelligence tasks. The state-of-the-art pre-trained models, such as CodeBERT, require the availability of large-scale code corpora. However, gathering training samples can be costly and infeasible for domain-specific languages such as Solidity for smart contracts. The large pre-trained model can easily overfit scarce data, which leads to poor task fitting. In this paper, we propose Zcaller, a novel approach for learning program representations without labeled data samples of the target language. We employ prompt learning, which adapts the downstream task to the same form as that in pre-training through a company trainable prompt token with a PM input. In this way, the model can be adapted to the target language while maximizing the use of prior knowledge learned during the pre-training phase. Hence, prompt learning allows few-shoot or even zero-shoot learning for pre-trained models in new languages with unlabeled data. We conduct extensive experiments on 3 code intelligence tasks. Results show that our approach significantly outperforms the baseline models. This figure shows that the workflow of Zcaller. By employing prompt learning, we train the PIM using large-scale code corpora in popular languages like Java through the converted task, and then directly apply the trained model to tasks in the low-resource language. The pipeline of Zcaller is comprised of 3 steps. First, we cast any downstream task to the pre-trained task by inserting trainable prompt and a mask token into the input of the task. The mask token acts as a placeholder, which steers the pre-trained model to generate the classification result in the code intelligence task. Taking the resulting data as input, a PIM is then retrained using the task. That is, infers the program representations of the input and predicts the word of the mask token. Finally, a verbalizer is employed to cast the predicts word to class labels. In our approach, we consider 2 candidate words, yes and no, as a candidate set and only inspect which word in the set is more likely to fill into the mask position through PM predictions. If the word yes has a higher probability to fill in the mask position, the verbalizer will map it to the label true, and hence output a positive prediction for this task. We evaluate our approach on 3 popular code intelligence tasks, including code clone detection, code search, and method name prediction. We formulate them as classification problems and conduct experiments on 4 representative datasets, which are preprocessed for the balance of positive and negative samples. In RQ1 experiment, we compare our approach with 5 baseline models. We can observe that our approach shows greater performance than baseline models in code intelligence tasks for no-resource language. In RQ2 experiment, Zcaller shows effective performance with a few data samples. As in zero-shoot setting, Zcaller still keeps the best accuracy among all compared models in few-shoot setting. In RQ3, we have also observed that Zcaller is effective in monolingual few-shoot setting. and shows much stronger performance than that in the cross-language setting. The results of our K4 experiment indicate that the effectiveness of our approach is affected by prompt templates, resource, languages, and PM scales. In summary, this paper proposes Zcolor, a novel approach for zero-shoot program representation learning via prompt tuning. Zcolor improves traditional PIMs by introducing prompts into program representation learning. Experiments show that Zcolor outperforms baseline models in 3 code intelligence tasks in both zero-shoot and few-shoot settings. Program representations learned by Zcolor also demonstrate good generalizability for low or zero resource programming languages. That's the end of my presentation. If you have any questions, please contact me via this email address. Thanks for listening.